Welcome back. In this lesson, we will look at the lifecycle management activities that you can do on DB systems in Oracle Cloud Infrastructure. You can use the OCI console to perform the following tasks. Launching a database system, you can do a status check of the database creation once you launch your database, and after that, you can view the runtime status of the database. You can start, stop, or reboot DB systems in OCI console. Note that billing continues in the stop state for bare metal DB systems, but not for VM databases. You can scale CPU cores, scale up the number of enabled CPU cores in the system for bare metal DB systems only. In the case of VM database systems, you can increase the amount of block storage with no impact. Also note that terminating a DB system permanently deletes it and any databases running on it. So if for some reason you want to terminate a DB system, if you have any data that you would want to preserve from the database, you can do two things. One is to take a one-off database backup, which will basically preserve the database backup in the event you terminate the DB system, or before you terminate the DB system, you can use data pump to export the database into object storage, and then you can delete the DB system. And after a few days, if you think you no longer require the backups, you can delete it, and then you'll be fine. Let us now look at patching database systems as part of lifecycle management of OCI databases. OCI will automatically provide you patches on the console. At any given point, you can have n-1 patches available for you to apply on the console. You can run pre-check on the existing patches that are available, and once those pre-check processes run successfully, you can patch your database at the click of a button. In the case of Exadata and VM rack shapes, patches are applied in a rolling fashion. However, for single node DB systems, if Active Data Guard is configured, this can be leveraged by the patch service. Otherwise, you will have a downtime for single node DB systems when you are applying a patch. Patching is a two-step process. You first patch the DB system, and then you patch the database. The screenshot at the bottom of the slide shows you how you can run pre-check and apply patches for your DB systems and the database in OCI console. You can use OCI's identity and access management controls to control who can list patches, apply them, etc. This is useful when you have many database administrators in your organization and you want to give the ability to apply patches to only a select few. So basically you will create multiple groups in identity and access management and put the database administrators who can apply patches into the IAM group, which has the permissions for applying patches. We will now look at the database backup and restore functionality for OCI database systems. This is a managed backup and restore feature for virtual machines and bare metal DB systems. Exadata backup process requires creating a backup config file. Backups can be stored in object or local storage. However, we recommend that you store backups in object storage for high durability. Database systems in private subnets can leverage the service gateway for storing backups in object storage. In the case of backup options, we have the automatic incremental backups which runs once per day and repeats the cycle every day, and by default these backups are retained for 30 days. On-demand standalone full backups are stored till the point you decide to delete it from the OCI console. You can restore a database to the latest backup, or you can restore the database to the timestamp. And finally, you can also restore the database to a particular system change number or SCN. Let's now look at some information on automatic backups. By default, automatic backups are written to Oracle-owned object storage. Customers will not be able to view the object storage backups. The default policy cannot be changed at this time. Automatic backups enabled for the first time after November 20, 2018 on any database will run between midnight and 6 a.m. in the time zone of the DB system's region. You can optionally specify a 2-hour scheduling window for your database during which the automatic backup process will begin. These are the preset retention periods for automatic backups: 7 days, 15 days, 30 days, 45 days, and 60 days. Backup jobs are designed to be automatically retried. Also note that Oracle automatically gets notified if a backup job is stuck. All backups to cloud object storage are encrypted. There's a link at the bottom of the slide which will give you more information on troubleshooting backups in case a backup job fails. Let's now look at high availability and scalability. OCI has robust infrastructure. It has regions with 3 availability domains architecture. It has fully redundant and non-blocking networking fabric. And you have the option of 2-way or 3-way mirrored storage for databases. In the case of Exadata, it has redundant InfiniBand fabric for cluster networking. In the case of high availability, Oracle Cloud Infrastructure DB Systems has 2 options. One is the database rack option in virtual machines and Exadata, and the other one is the automated data guard deployment within and across availability domains for VMs and bare metal shapes. As I mentioned in the previous lesson, OCI DB systems also have dynamic CPU scaling for bare metal shapes and storage scaling for VM DB systems. Oracle Data Guard is supported on both virtual machine and bare metal DB systems. It is limited to 1 standby database per primary database on OCI. If the customer has a database license for Active Data Guard or deploys the Oracle Enterprise Extreme Performance package, they can use the standby database in a data guard setup for queries, reporting, running tests, or backing up the database from the standby. You can do switchover, which has planned role reversal without any data loss. In this case, no database reinstantiation is required, and it's typically used for database upgrades, tech refresh, data center moves, etc. This can be manually invoked via Enterprise Manager, DGMGRL, or SQL+. For failover, you can do unplanned failover of primary, and the flashback database is used to reinstate original primary database. It can be manually invoked via Enterprise Manager, DGMGRL, or SQL Plus. It can also be done automatically using Fast Start failover. Let us now look at the security features for database service. For customers looking at instance isolation, OCI DB systems provides customers with the bare metal DB systems. In the case of customers who want to ensure that their DB systems are running in a very secure fashion, they can use the features of the OCI network infrastructure to deploy a virtual cloud network and configure security lists and rules so that the databases are deployed properly in private subnets and traffic is isolated only to the applications that are deployed on the OCI infrastructure. Customers can securely connect from their on-premises environment to OCI using VPN and Fast Connect, which uses the dynamic routing gateways for VCNs in Oracle Cloud Infrastructure. In the case of user authentication and authorization, OCI segregates each customer into their own tenancy, and each tenancy can be further divided into compartments to isolate workloads for different departments or different phases of a particular project like test, dev, or production. Customers can configure identity and access management policies to uh, determine which user gets access to a particular compartment. Customers can also control access to the console using the identity and access management, user IDs, and group permissions. Finally, if customers are going to use APIs or Terraform to access OCI, then they will require an API signing key which can be also controlled and shared with only the folks who are spinning up infrastructure using APIs. All access to the DB systems running in OCI will require a private SSH key which goes with the public SSH key used during the deployment of the DB system. In the case of data encryption, transparent data encryption is included with all the database editions that are provisioned on Oracle Cloud Infrastructure DB systems. Customers have the ability to encrypt RMAN backups, and the local storage and object storage is also encrypted at rest. If customers want to have end-to-end TLS for their applications, they can consider using the load balancer service with TLS 1.2. The customer will have to provide the certificates for this. And finally, the auditing service logs all the activities that happen on the console or via the API, and auditors can look at this auditing service to look at who creates a particular resource or who deletes a particular resource in Oracle Cloud Infrastructure. Here's a quick look at the pricing information for DB systems on Oracle Cloud Infrastructure. I won't go through all these numbers, but you can look at this information on www.oracle.com/database/vm-cloud-pricing.html. So to summarize, Over the course of these lessons, you learned about the database service offerings for Oracle database in OCI. You learned about Exadata, real application clusters, the bare metal and VM shapes that allow customers to deploy every kind of enterprise applications. These databases provide lifecycle automation for customers from provisioning, patching, backup to restore. Customers can scale from one core VM to Exadata and have high availability options, namely DataGuard and real application clusters. OCI DB systems also provides customers with robust security controls and allows customers to leverage the on-premises licenses to deploy Oracle Cloud Infrastructure DB systems. Thanks for watching this lesson.